Good afternoon, students.
Good afternoon, sir.
Welcome to mathematics class today. How are you today?
Fine, thank you.
You sure? You had a good weekend?
Yes, sir.
All right, and are you looking forward to classes today?
Yes, sir.
All right, has somebody make a guess what we'll be doing in this lesson today? All right, let me help you. Let's say I went to a store and I tell you, look, I purchased a particular item for $1,000, but the actual price for the item was not 1,000, but I just say 1,000. Yes, what you say?
Profit and loss.
Not profit and loss. That's an example which appear to be profit and loss, but it's not profit and loss. Remember, hear carefully. I just tell you, oh, I pay $1,000 for this thing, but it is not 1,000. It was somewhere about 1,000. But I just say 1,000. You say average. I think I heard the answer from you.
Sir,
No, I didn't hear it from you. Yes.
sir, profit percentage.
Profit percentage? No, not profit percentage. And you do not have to stand, right? All right, let me start it. We'll be looking at the topic, but it begins with A.
Algebra.
Okay.
Approximately.
Approximation. Correct. Good. We'll be looking at approximation today. Yes, approximation. Yes, can you tell me other ways in which you could approximate? Somebody give me another example of approximation. You ever hear anybody approximate a figure? You may ask them, what is the price of something? Right? You go at courts, eh? Your parents shop at courts? Well, sometimes, we shop at courts. And if you buy something for, let's say, for $49,999, how much you think you will tell persons you pay for this thing? Yeah, with 50,000, you wouldn't want to remember the whole figure. So you might want to just, give a figure close to what it really is, but it is not that figure. So, how do we define approximation? What really is approximation? Approximation refers to an inexact value. What type of value?
Inexact value.
Yes, an inexact value or an inexact representation of something. But this inexact representation is so close that it can be used in the place of the actual number or of the actual whatever we are approximating. Is that clear?
Yes.
So rather than saying 49,999, we might want to say, oh, let us approximate that to 50,000. Rather than I saying that I purchased a particular ledger book for $985, I might just say that I purchased it for $1,000. Very good. So we can approximate a given number to find an inexact representation which is so close it could still be used in the place of that number. Is that clear?
Yes, sir.
So we might want to know, how do we usually go about approximating? There are three ways that we can approximate, for which today we'll be looking at basically two of them. All right? We can approximate in terms of what is that?
Significant figures.
Yes, significant figures. We can approximate in terms of significant figures. We can approximate in terms of
Place
value. Yes, we can in terms of place value, whether it be maybe to the nearest 100 or to the nearest 1,000 or to the nearest tens, we can approximate like that. Is that clear?
Yes, sir.
Good. But then there's a third one which we will look at in today's lesson also. We can also approximate in terms of the decimal place, because some numbers, remember, some numbers have some decimal digits following. So sometimes we might be interested in, maybe we might just want to know this number to the first decimal place or to the second decimal place. We're not interested in anything else that follow. All right? So we can approximate like that. In today's lesson, we will be looking at the place value, approximating in terms of place value, and in terms of decimal place for the rest of today's lesson. Is that clear?
Yes, sir.
But if we're going to approximate using these, we have to follow some steps. It is good if we could have some defined steps that we follow, which can help us to that if we remember those steps, we'll be able to approximate almost any number. And in order for us to master those steps, we're going to do them as we consider a few examples. So I'm going to give you a few examples here, and we're going to look at the steps that we have to follow even as we solve these problems. So let's consider the first example. Imagine if we have this number. We may want to approximate 23.1476 to 2 decimal places. Now, let us consider another example. We may have we may have 1,495, and we want to approximate that to the nearest 10. Let's take a third example that we're going to look at. If we have these three numbers, 23.1476, 1,495, and 0.013257. The first one we need to take it to 2 decimal place, the second one to the nearest 10, and the third one to 4 decimal place. So what does this mean? All it is saying to us is that instead of giving the entire number, all right, instead of giving the entire number, we are just interested in the number beginning from the left up to a certain digit. So we need to figure out certain steps. How do we come up with such an approximation? Anybody want to know how we come up with such an approximation? So nobody want to know?
Yes, sir.
Okay, because then I will say, well then, we don't have to teach you because you guys already know this. Good, so let us see how we come up with such an approximation. The first step we look at is to determine whether we are looking for a place value or whether we are looking more precisely for a decimal place. So we have to look at each example and determine, is this a place value example or is it a decimal place example? So let us consider the examples. What about the first one? Is it place value or decimal place?
Decimal place.
The second one?
Place value.
The third one?
Decimal place.
Good, so we have identified what we're looking for. So, having the place value, the next step we do is to look to see where is our cutoff point. Up to which digit in this number are we interested in? Okay? Up to which digit are we interested in? So we look at the first number. We're interested in this entire number, but up to the second decimal place. Now the decimal place refers to the digits that come after the decimal point. Do you agree with me?
Yes, sir.
Good. So, which is the second decimal place here? Which digit is in it? 1, 4, 7, or 6?
4.
The second digit after the decimal point is? 4. So we are interested in this number up to 4. That's what we're interested in. We want everything coming back here. So we have to discard of the rest. But we don't just discard of it just like that. There are some other things which we have to consider. All right? What about the second number? Up to where are we interested in? 1, 4, 9, or 5?
9.
9.
Yes, we're interested up to the 9 because we want to the nearest 10. So we're looking for the place value of 10. So anything which comes after the place value of 10, we want to discard of it. Throw it into the waste basket. Huh? So we want from 9 going back for this number here. What about this one here? Up to where we want?
2.
This is the first, the second, the third, the fourth. So we want up to the fourth because it's 4 decimal places we want. So we're taking this up to here. So let us go through the steps which we have done so far. We first determine whether it is decimal place or whether it is a place value. And we found out that the first and the third number deals with decimal place. But the second one, which is 1,495, to the nearest 10, well then we're talking about approximating based on this place value. Alright?
Yes, sir.
Good. What do you think is our next step?
So I'm taking it to the 2 decimal place.
Next step is to take it to the 2 decimal place. Now remember I said, we're going to come back taking it to 2 decimal place because we know that's what we want, to take this to 2 decimal place. But remember I said just now, we have to discard of everything after this line. Or we don't just throw it away like that. You know, you don't just throw away things, you know. Sometimes you're cleaning up your room. I know some of you are cleaning up your room for a couple months. Yeah, just clean up your room every week.
Yes, sir.
Some persons look at me to say no. Mommy just clean it for me. Good. But you know, even if you're going to clean up, when the school closed and you decide to clean up your school bag, you're going to start taking out everything and you might decide what you're going to throw away. But then sometimes before you throw away something, you pull out something out of the bag, and before you throw it away, you might say, I wonder if I can use this thing. Any way I can use it? If there's any way that you can use it, well then you might keep it. If there's no way that you could use it, you might then just throw it away, man. So these numbers to the left of this line here, this is our border line, and these numbers to the left, we have to look back at them again to determine whether we could just discard of them just like that, or whether there's anything about them that we can keep. So this is how we determine what we can keep to what we cannot keep. In approximating, the next step says we need to look at the digit immediately after the one that we desire. So for example, we desire up to 4. We're interested in a number up to 4. So which is the digit that follows 4? 7. The digit that follows 9 here?
5.
And the digit that follows 2 here is?
5.
Good. So it says look at the digit which follows immediately after, and if that digit is less than 5, if it is what?
Less than 5.
Yes, if that digit is less than 5, well then you keep all the numbers just as they are without changing it. Okay? So let us see. In this case, is this digit less than 5?
No,
Well,
sir.
we're going to come back to that number. Is this one less than 5?
No,
Is
sir.
this one less than 5?
No,
So
sir.
none of them less than 5. So we do not have to apply that here. But then if we do not have any that satisfy the less than 5, well then we look to see those digits if the digit is more than 5. Now remember, less than 5 says that if it is less than 5, we keep the number as it is. So for example, let me just give a fourth one here. Yes, consider this other number here, 13,741, and we wish to round this to the nearest 100. So, if we're going to round it to the nearest 100, we have to find our cutoff point. Up to which digit are we interested in?
7.
1, 3, 7, 4, or 1? Up to which one we're interested in?
7.
7, correct. We're interested up to 7. So we put our borderline here. So we have to discard whatever is left back. But we now need to look at it to see whether there's any value in what is left back. Now the rounding off rule says that if this digit which comes after is less than 5, well then everything which is left back must just be thrown away. they have no value. Okay? So
Yes.
we say that this number here, this number 13741 can be approximated, and this is the sign we use for approximating. It's just like the equal sign, but like if you bend it up a little, good, it's just like the equal sign, but if you bend it up a little. So this number here can be approximated. It says to keep 137 and discard the rest, remove the rest. But then if you remove these two, what will you be left with? 0, 0. Because if you remove the 4, it means you're left with nothing, which is 0. You remove the 1, you're left with nothing, which is 0. So 13,741, when rounded to the nearest 100, will give us 13,700. Because everything after the 7 is worthless, man. Discard of it. We don't want that. Yeah. So we consider a number for which after the cutoff point it is less than 5. What about if it is more than 5? What the rule says if it is more than 5? Anybody want to say? If it is more than 5, no, if it is less than 4, we leave it as it is. As in this case, as in D, if it is more than 4, we leave it as it is. If it is, less than 5. If it is more than 5, what do you think we should do? We will have to do the opposite. If it is more than 5, well, then we have to do something to this number which comes before. The rule says if it is more than 5, this is our next step. If it is more than 5, this number which comes after the one which we want, if it is more than 5, well, then we increase the boundary number, the last number that we're interested in. We increase that number by 1. Yes, we increase it by how much? 1. So let us go through these examples. We finished solving D. We finished with D. So let us go through A, B, and C to see if after this cutoff point, whether the digit that follows is more than 5. What about A? The digit that follows 4. Is this more than 5?
Yes.
So what do we do with 4?
Add 1.
And it becomes 5. So then we can say that 23.1476 is approximately equal to, you tell me what to write? 0.15. Full stop. Excellent. All right? So if the digit which comes after is more than 5, well, then we increase the one up to which we want. So we look at if it is less than 5, if it is more than 5. What about the other two numbers? B and C. You see, this is exactly 5, and C is exactly 5. So therefore means there must be a third rule, because we look at 2 rules so far. If it is less than 5, we keep the number as it is, and just discard of the waste. If it is more than 5, before we discard of the waste, we increase this by 1. If it is exactly 5, what do you think we should do? If it is less than, it says keep the number as it is. If it is more than, it says increase it by 1. If it is exactly, what do you think we should do? Something to think about, eh?
So just leave it just like
Just leave it just like that. So it would be as if it is less than 4. All right. If the number is exactly 5, this number which comes after here, if it is exactly 5, well, then we have 2 options. We need to now look back at the previous digit. What we need to do?
Look back at the previous.
And what we're looking for is to see whether the previous digit is odd or even. And if it is odd, we apply the same rule which says if it is more than 5, which is to increase by 1. And if it is even, we keep the number as it is. Let me go that again. If the previous digit, if up to the cutoff point that we want, if this number here is odd and the following one is 5, well, then we increase this by 1. However, if this number is even and the following number is 5, well, we keep this number. We do not interfere with it. We just discard of the 5 without doing anything. Is that clear?
Yes.
So let us examine B and C to see what it will be. You tell me what to write. I will say that 1495 is approximately equal to
1/5.
1, 4,
1 0.
1.
1, 0. What do we do with the 9?
Add 1.
Add 1.
So when we add 1 to the 9, what happens?
Get
Get
10.
10.
It becomes 10, so then we can look back. If we add 1 to 49, what it becomes?
50.
50. So actually, this number should be 1, 5, 0. Okay, but observe that this was a whole number. So what do we do with this here? We replace it with 0. We replace it with 0. Now observe, somebody might be questioning, why for these two we replace with 0, but then for this one we did not replace with 0? Of course we can replace this with 0. We can replace the 7 and the 6 with 0. But it looks kind of weird now, eh? For you to have 23.1500. Why have 23.1500? That 00 at the end really doesn't make much sense. So that is why usually once it is after the decimal point and then zeros are following, we just drop the zeros. But we cannot drop the zeros here because this is what you will be saying. That you will be saying that 1,495 is equal to 150. Is 150 close to 1,495?
No, sir.
No. And I know if some of you do calculations like this, I would love to do business with you, you know. All right? Because I'm going to come to your store and I'm going to buy something for 1,495 and I'm going to ask you to approximate how much money I have for you. And you're going to look at this figure and you're going to say, oh, you have 150 for me. And I will say, sure, first word, take out my 150 and give you, eh? But I don't want that to happen to you when you get older and you have your own business and so on. I don't want anybody to do that to you. So that's why we're looking at the correct thing. So when we approximate here, in this case, the 9 is increasing by 1. So when we look at it now, when 49 is increased by 1, it becomes 50. Good. So we finish with, we did B, we did A previously, and that was B. What about C? Tell me what to write. I will say that 0.013257 is approximately equal to, tell me what to write.
0.0132.
Everybody agree with this?
Yes, sir.
All right, let me see if I agree with it too. All right, and I hope I agree with it too, because this was going up to 4 decimal places, and up to 4 decimal places you wanted to round this to, and the fourth one was 2, the number following is 5, this is exactly equal to 5, so I look back at this. Is it even?
Yes, sir.
Yes, 2 is an even number, so we keep it. We do not increase it by 1. So we finish with all 4 of these. Good? And this is how we round off any number to a given decimal place, to a given place value. Have you learned how to do this now?
Yes, sir.
Good. I'm happy that you have learned, because it means now that I can give you some tough examples to really see whether you have learned. So just finish off copying this quickly and then I will give you some tough examples and we're going to see how you could answer those. Okay, I see some of you are finished copying, so then you are ready for some tough examples, are you? In
Yes.
approximation. Is there anyone sitting here who feel that they will get all the problems correct that I give to you? Just raise your hand. Anybody feel you get all the problems? So we have 1 confident, 2 confident students that they will get all correct. Your hand is up too? So you're not confident. You might get 1 wrong. Okay, she thinks she might get 1 wrong. She's not saying 100% she will get all correct. Well, I hope that you get all correct though. So, let us consider the number. Now, look at that number. Can someone please call this number for me?
3,257.
3,257. Now, when 3,257, we're going to look at place value rounding now. We're rounding according to place value. And when 3,257 is rounded to the nearest 10. Don't answer us yet. When it is rounded to the nearest 10. Who's going to answer? Yes, what you said is you're going to get all correct, right? I will have to remember that. When 3,257 is rounded to the nearest 10, the answer is?
3,260.
3,260. Anybody disagree with him? Well, I don't disagree with you either. 3,260. All right, for this first one, let me just go through again the steps. The first thing, you identify whether it is place value or not, but it is place value we're dealing with. Then we identify up to which digit we want. We want up to the nearest 10, so we put our mark there. We look at the number which follows. Is it bigger than 5?
Yes,
sir.
Yes, so then what do we do with this one? Increase by 1, and that's what we did. And because this is a whole number here, it is not after a decimal point, we replace this with 0. Good. Same number to the nearest 100. Let me get someone else who's going to answer now. To the nearest 100. Quickly, who's going to answer? 3,257 to the nearest 100. Okay, you're going to answer again.
3,200.
3,200. And because I didn't get... Anybody agree with him? 3,200? All right, we have a few persons agreeing with him. But because I did not get everyone to agree, let us just confirm how we get 3,200 again. We want to the nearest 100. Which digit is in the 100 place?
2.
The 2, so we want from 2 here. Good. The number after 2 is?
5.
5. That's exactly 5. So now we look back at this. Is this an even number?
Yes, sir.
Yes, it is even, so therefore means we do not increase it. So we keep the 3, 2, and we replace the others with 0. So it becomes 3,200. Lastly, for this one, same number, 3,257 to the nearest 1,000. This one should be fast now. To the nearest 1,000, what will this one be?
3,000.
3,000. Correct, because we want up to the 3 here. So the number which follows is less than 5. So this is when to the nearest 1,000 is 3,000. Great? Is that clear?
Yes, sir.
Good. So this is to place value. Let us take a few examples quickly, very similar, but this time we're going to look at decimal places. Consider this number, 78.2615. 78.2615. When this is rounded or when we approximate it to 1 decimal place, 1 decimal place we're looking at. Who's going to answer? Yes. I know she wants to answer. What is it?
Between the 2
Good.
and
So
6.
all right, you said we put this line between the 2 and 6, This is more or less than 5?
So yeah, add 1 to
It
it.
is more than 5, so we add 1 here. And what will we get? Tell me what to write.
78.3.
78.3. Now we can replace everything here with zeros, but it wouldn't make much sense because after all, it is already past the decimal point. It would not change the number. So that is the 1 decimal place. Same number, 78.2615 to 2 decimal place. Who's going to answer? 78.2615. You're going to answer again.
6 and the 1.
Between 6 and 1, so we want up to 2 decimal places, which is up to the 6.
And 1. And
Good.
put 7, 7, 8.
78 point
2.3.
78.3. Now let us come back here. Anyone agree with her? 78.3?
No, sir.
We have a few persons disagree with you. So it means something. So many people can't disagree with you, man. So one person who's disagreeing with her, what do you think the answer should be?
78.26.
78.26. 78.26. All right. Let us see where you went wrong, right? So the next time you will not go wrong again. We want it up to the 6. So we check to see, is the number after 6 more than 5 or less than 5? Less than 5. So it says we keep this whole number as it is. We're not dropping the 6, we're keeping everything coming back here. Good. 78.2615 to 3 decimal place is, quickly, 78.2615.
78.26.
78.26. Anybody disagree? You say what you say? You say it should be 2.
Yes, sir. Yes, sir.
Some persons now say they think it should be end with 2 and not the 1.
1 is an odd number.
Yeah, remember we want up to 1. Good? So we look the number after. Is it more or less than 5? It is 5. So now we have to come back and check again. Is this odd or even?
Odd.
It's odd. And if it is odd, then we have to increase by. So this should be 78.262. Good? Very good, very good. So we look at decimal place, we look at that. Now what about if we look at approximating to the nearest whole number? Approximating the nearest whole number. So to approximate to the nearest whole number, it means to get rid of the decimal part of the number. We just want the whole number. So as if somebody coming to you and they ask you, what is the price for this marker? And the person, and you ask them, what is the price of this marker? And the person tell you, oh, it is $150.17. Where you gonna find 17 cents to pay them from? So in cases like that, you might want to round off. All right? And if they say it's $150.17, and then they tell you, but to the nearest dollar, this is equal to 151. Will you agree with them? That they will tell you, oh, it is 150 and 17 cents, 150.17, but to the nearest dollar, man, just give me 151. Hmm? Yeah, because this isn't close to 151 as it's close to 150. All right, this is closer to 150 than it is to 151. So we need to know to round to the nearest whole number. $78.415 to the nearest whole. $78.415 to the nearest whole number. It means our cutoff point is right at the decimal point. We do not want the things that follow the decimal point. So what should the answer be?
78.
78, flat 78, correct. Everyone say we get 78? Yes, because we want up to that whole number there. So the nearest whole number is?
125.
Well, are you sure? Anybody disagree?
No, sir.
You sure it's not 125? You sure it's not 126? I believe it's 126. Tell me why it is not 126. Somebody tell me why it is not 126.
Because the 2 is less than 5.
The number after the decimal place is
Less than 5.
less than 5. So it means I cannot round up. I have to keep it at 125. Correct. Let me try a third one. I want a tough one for you this time, huh? To the nearest whole number, what is this?
5,769.
5,000.
769.
5,769. Good, correct. Lastly. Mm-hmm.
1.
One.
Somebody say 1. Who agree with 1? Let me see those who agree with 1. How will we get 1?
More than 5.
The 8 is more than 5, so we increase the previous digit by 1. So 0 now becomes
1.
1. Very good. All right. So, anybody learned something new about approximating today? Huh? So nobody learned something new?
Yes.
Good. So someone learned something new. Good. I'm happy. And I hope that in future, anytime you go to approximate, you will be able to apply what you learned today in approximating. All right? I enjoyed today's lesson. I don't know about you.
Yes, sir.
Good. All right. And I look forward to the other lessons. Good? Because I love mathematics. Anybody love mathematics here?
Yes.
I'm seeing some hands. Well, hear what? I hope that by the time we complete these classes, all of you will fall in love with mathematics. All right? Good. So we will stop here for today. If any of you have a question then? Before we go? Any of you have a question? All right. Well, let us stop here for this lesson. And I look forward to seeing you for the next lesson. Great? Okay. Bye then.